Hello, everyone. My name is Gail Zedleski. I'm the director of the Maine Sea Grant program here at the University of Maine and a faculty member in the School of Marine Sciences. And I'm here to introduce you to a new initiative at the university called UMaine Marine. And I'm going to actually turn this over to Dave Townsend in a moment to tell us a little more about that. But before we do that, I would like to just point out the question and answer box. This is a webinar, unlike some other Zoom experiences you may have had. This one's a little different since you're not here with us in the with the panelists, but we have a set of panelists who will be talking with you today. If you have questions for us, you need to put those questions in the Q&A box. And I will be looking at those and bringing them up as we go. But we thought we'd do a little bit of a presentation with some videos for you to get to know what's happening at the University of Maine in this space. And without further ado, I would like to introduce David Townsend, Dr. David Townsend, a professor of oceanography and the director of the University of Maine School of Marine Sciences. He was born and grew up in Maine and is a UMaine alum, having received his BA and PhD degrees from Maine with an MS from Long Island University. He is a biological oceanographer and studies plankton and nutrient dynamics, especially in the Gulf of Maine. And he teaches undergraduate and graduate classes in oceanography. And he'll be introducing UMaine Marine to you. Take it away, Dave.
All right, thank you, Gail. Well, the first question I think Gail did answer, what is UMaine Marine? And it's defined on your first slide. It's a clever acronym to come up with some words for those 6 letters. It's Marine Aligned Research, Innovation, and Nationally Recognized Education. So what is our goal? Our goal is to bring together the various marine-related resources that we have here at the University of Maine and University of Maine Machias in order to facilitate better coordination, collaborations, and interactions amongst us on marine topics of interest, especially those related to research, education, and outreach. So currently, of course, we're UMaine and UMaine Machias centered, but our longer term goal is to grow statewide to include both public and private entities, industry, government, and community collaborators, et cetera. And it's important to point out that UMaine Marine includes not only the ocean and the coast, but also our connected estuaries and freshwater systems. And I'll say a word about those in just a minute. So why are we doing this? Why are we launching this initiative? Why do we think it's important? Well, for one thing, the effort is a natural outcome of our Maine's rich nautical and maritime heritage, our history, and our centuries-long dependence for our livelihoods on the ocean and its living marine resources, for example, but also shipping, logging, extraction of food, and more recently, leisure and entertainment here in vacation land, after all. And also, it's no secret that Maine's population is tightly packed or squeezed up against our long and indented coastline, from the more densely populated counties down in western Maine, York and Cumberland counties, to the more sparsely populated Downeast counties. But regardless of population densities along the coast, the ocean, Maine's ocean, its coastal environment, are in our blood. And as such, our coastal ocean, which is the Gulf of Maine, defines us in a lot of different ways. But it isn't just the ocean. Tightly coupled to our coastal ocean are Maine's 600 or so lakes and ponds, 70 or so rivers that exceed 20 miles in length, all of which empty their freshwater molecules at some point into the ocean, into the Gulf of Maine on the Maine coast. Now, those freshwaters, of course, are a resource that's both valuable and abundant here in Maine, but they need to be better understood and protected, and the interconnections fully understood. So Maine's coastal ocean, the Gulf of Maine, and its coastline and connected freshwater environments are all important to Maine's future, we would argue, in terms of economic development, in terms of aquaculture, tourism, recreation, fisheries, ship and boat building, energy extraction, all of which will depend on environmental quality, which it's our obligation to safeguard that environmental quality in our roles of researchers and as educators. And that brings me to the topic of education and extension, which are critical. So only by way of a better understanding by a greater number of citizens here in Maine can we both protect and benefit from this rich but vulnerable public resource. And so at this point, I'm going to hand it back to Gail, who can talk a little bit about education and extension.
Thanks, Dave. So one of the things that you might notice in this map anyway is where is UMaine Marine? And you might think about the University of Maine as being in Orono, but what you'll see is a lot of the work that we do stretches along the entire coast of Maine and really touches on all the aspects that Dave mentioned. So one of the things I'll point out here is remind us that the University of Maine is a land grant, sea grant institution. And as a sea grant institution, we have a partnership with the Cooperative Extension, and we have a marine extension program. And all the yellow diamonds that you see on this map represent places in Maine where we have extension professionals, people from the University of Maine through the Sea Grant program who are living in those communities and connecting with researchers at the university and other institutions to bring marine science to Maine's people. So really that's the outreach extension piece, bringing not only the research, but the educational opportunities across the coast of Maine. So I just wanted to point out those yellow diamonds, but also point out that we have different locations along in various different places in Maine where we have different institutions doing work that is marine related. So I thought we would switch now. I'll introduce you to a few folks who are part of the current UMaine Marine Initiative and really remind us that, as Dave mentioned, and you'll see, and a lot of what you'll see in the next few minutes, is that this is about Maine as a whole. And so we have lots of partners, lots of people we work with to make the research that we do and the education that we associate with that really meaningful to the state of Maine. So with that, I think we'll queue up first the School of Marine Sciences video. Tammy? And I'll just point out that this video is a video you'll see Dave and other researchers from the University of Maine talking about the School of Marine Sciences first. Thanks.
The Earth is composed 70% of oceans. And look at the state of Maine. We have over 4,000 miles of coastline. A great many of our industries, our resources are marine related.
Our identity is deeply linked to the coast and the ocean. We are people who love to be out on the water, whether it's sailing or catching fish or just exploring new places. The ocean is really important to our cultural identity.
Our coastal economy in the state of Maine is huge.
We try to find an optimal level of a catch so that both fisher population and fisher industry can benefit from the fisheries.
That lobster model changed the dynamics in lobster management within the Gulf of Maine.
These buoys that we designed are out there 24/7. They're sending data back to the public and to all scientists every hour.
Every fisherman I know uses it every day to see what the real conditions are then and look at the forecast for what they're gonna be.
It's the nation's largest fishery. It's Maine's largest export.
So now over 80% of our value comes from one species. That's a dangerous place to be.
We try to keep our finger on the pulse of those babies entering the population.
This is a window into problems that are global in scope.
When the eyes appear, I know that there's actually an embryo inside here.
If we can reduce embryo mortality, then all of a sudden that increases their bottom line, and that's a really important factor for them.
We have new vaccines that are going into fish for sea lice. If we can have a major breakthrough there, then we have a mechanism to control the most damaging disease in salmon aquaculture today.
Red tides are one of the biggest public health concerns we have in the Gulf Maine regions. We need to know when to expect these events to occur. We need to know where on the coast to be looking for it first.
When you look at the demand for seafood and you couple that with Maine's enormous coastline, it's a natural fit.
But there's a lot of opportunity for growth within the industry, and to the degree that the university can help, we're there and working with industry partners.
In terms of the tidal power development, knowing what is the risk to different fish populations is what we're trying to get at.
They've been able to really develop technologies, methodologies to get to some of the key answers around how marine life interacts with our power systems.
And marine policy has a special role to play in that in terms of being able to translate all of the work that biophysical scientists are doing to solutions on the ground so people can understand it and say, oh yeah, that makes sense.
Everything is all connected together. The deep ocean is connected to the shallow water is connected to the land is connected to the deep ocean. We have to study all of these processes to begin to understand how the world really functions.
We've seen an undersea revolution on the coast of Maine.
Marine science has never been more important in the Gulf of Maine region.
We have a number of faculty focused on our backyard, Gulf of Maine, but we understand that the problems in the ocean is global.
This close link between human well-being and ocean health is really important to understand.
Our mission is to educate students in the marine sciences with the goal of promoting sustainability of the oceans.
Thanks. So that's a video explaining some of the work being done in the School of Marine Sciences, but there are many other groups of folks working in marine related areas. So next I'd love to introduce to you somebody from the University of Maine's Aquaculture Research Institute, and that's Dr. Debbie Bouchard. She's the director of UMaine's Aquaculture Research Institute and an assistant professor of aquatic animal health with UMaine's Cooperative Extension. She has over 30 years of combined public and private sector experience in aquatic animal health diagnostics, research, and industry collaborations. So Debbie will introduce you to the lab, and then we'll show you a short video about the work being done there.
Thank you, Gail. Yes, we're going to show you a little video about the Aquatic Animal Health Lab, and this will show our student engagement with aquaculture research at the University of Maine. You'll see Alex Sullivan. He is University of Maine senior majoring in marine science with a concentration in aquaculture. He's been working with the Aquaculture Research Institute for 3 years and will share some of the experiences he has gained at UMaine Cooperative Extension's Diagnostic Research Laboratory.
And as the video is queued up, I'll just tell folks who are attending that if they want to put any questions in the question and answer as things come up, feel free to do that, and I'll keep track of those.
Thank you.
Hello and welcome to the University of Maine Diagnostic and Research Laboratory. My name is Alex Sullivan and I am a senior here at the University of Maine studying marine science with a concentration in aquaculture. I've been with the Aquaculture Research Institute for about 3 years now. Let me give you a tour of this facility and show you the type of aquaculture research that we do here. The University of Maine Diagnostic and Research Laboratory was built in order to identify, research, and address pathogens that affect key crops that are critical to Maine's agricultural economy. Our lab division, the Aquatic Animal Health Lab, investigates pathogens that affect aquaculture organisms such as salmon and shellfish. Aquaculture is a rapidly growing sector of agriculture worldwide, especially in Maine. With the development of new seaweed, shellfish, and salmon farms, this lab will serve to aid in the improvement and further development of these sectors. This is our largest aquatic lab, which houses a single recirculating aquaculture system with 21 125-gallon tanks. We use the system for many of our larger-scaled finfish research studies. Smaller-scaled projects can be conducted in this lab. I've personally assisted researchers with several freshwater and saltwater projects in this lab, including a lobster and salmon trial. During my time working with ARI, I've aided in system construction and renovations, animal husbandry, and other tasks such as making saltwater, a task that is necessary as we are an inland lab. Currently, we are running a project from a grant funded in collaboration with Northeastern University. This project is currently investigating the safety and efficacy of a novel adjuvant for fish vaccines, which are commonly used in fish aquaculture to ensure the health of the fish. In vaccines, an adjuvant is the matrix in which a vaccine is delivered, which helps to 1. Deliver the antigen to the host, and 2, effectively ramp up immune response in the host. From this project, we hope to improve the effectiveness of certain fish vaccines. Using this laboratory to collaborate with colleagues from different universities provides unique and useful research opportunities which would otherwise not be possible. Projects such as these are crucial to the further research and development of aquaculture in both Maine and nationwide. The ability for me to have become involved with the many projects going on here at the Diagnostic and Research Laboratory have been a tremendous opportunity for me. Working here has provided me a unique and hands-on experience that I would not have been able to have anywhere else. The skills, knowledge, and connections that I have made at my time here are invaluable and will certainly serve me well in my field in the future.
Thanks. Thank you, Alex. And that was a really great demonstration of how at the University of Maine, we really try to connect students with research and at all different levels. So as soon as we can get them into those types of situations, we try to do that. So at this point, I'd love for maybe Tammy, if you could bring up the map. So we just visited with folks in Orono, and then also the diagnostics lab isn't right at the University of Maine campus, but right nearby. And so the next folks, or the next place I'd like to take you to is in Franklin, shown here, the Center for Cooperative Aquaculture Research. And I'm going to introduce you now to the director of that center, Steve Eddy. He's also the science advisor for Maine Coast Sea Vegetables. He grew up in Vermont, but migrated west after college, and he's been working in fisheries and aquaculture ever since. He told me when he considered moving back east, he visualized living on an island in Maine, or at least near the coast. So to all the skeptics out there, visualizing your future, you can actually make it work. So I'll turn it over to Steve to introduce this video.
Well, thank you, Gail, for the introduction, and thank you, everyone who joined us for being here today. It's a really nice day out. I'll begin by saying how pleased I am as an aquaculture scientist to be part of the University of Maine's Marine Initiative. Aquaculture has been part of Maine's marine tradition and economy for over a century. Although the first official aquaculture lease wasn't issued in Maine until 1973, aquaculture has actually been practiced here since the late 1800s. In 1997, the Maine legislature established the Maine Economic Improvement Fund, or MEIF. The MEIF targeted 7 technology sectors in Maine for investment, and aquaculture and marine sciences was one of them. As part of that initiative, in 1999, the University of Maine established the Center for Cooperative Aquaculture Research, located in Franklin on Thompson Bay. The Center for Cooperative Aquaculture Research is a great name, but it's also a mouthful. So most people simply know us by the initials CCAR or CCAR. CCAR was established with the idea of being a place where companies could work with university scientists to conduct industry-relevant research at meaningful scale, test and develop new species and methods, and in general use the facility as an aquaculture business incubator. Early projects included growing halibut and Atlantic cod as food fish, and marine worms for bait and aquafeeds. I was hired as a center biologist in 2000, shortly after CCAR was established. When I arrived, CCAR was much as it was from the early 1990s, when it had been a privately run salmon hatchery. At the time, it was the only salmon hatchery in the entire Northeast operated using recirculating aquaculture systems. In 2000, CCAR was still a functional aquaculture facility, but just barely. A lot of the infrastructure was becoming obsolete or even deteriorating. Over the next 20 years, with support from the state, federal government, and private sector, we've almost entirely rebuilt the facility and more than doubled its capacity. In particular, I want to acknowledge the Maine Technology Institute and the Maine Technology Asset Fund for their support and the improvements they've made possible. In 2005, the USDA ARS established the National Coldwater Marine Aquaculture Center right next door to CCAR. Together, we make up one of the most versatile, useful, user-friendly, and advanced aquaculture research and development facilities in the nation. And for me, this has been one of the greatest adventures of my life. Last year marked CCAR's 20th anniversary. We didn't do much to celebrate, mostly because 2020 just wasn't that kind of year. Normally, we welcome visitors, but our front gate has been closed since March 2020. Hopefully, soon, we'll reopen the gates to visitors, but for now, we can offer a video tour, which you're about to see. CCAR's education and outreach coordinator, Melissa Monstead, produced this tour that you're about to see using just her cell phone and computer. It's about 3 minutes long. I think she did a fantastic job, and I think you'll like it too. So thank you for tuning into this webinar, and I'll be available during the panel discussion for questions. Enjoy the video.
Aquaculture has the potential to tackle some of the most challenging social, economic, and environmental issues we face today. With a long tradition of fishing and working waterfronts, seafood and Maine are inextricably linked. Maine's aquaculturists are a leading supplier of fresh and sustainable seafood. Located on the shores of Taunton Bay in Franklin, Maine, the Center for Cooperative Aquaculture Research was founded in 1999 by the University of Maine and is co-located with the USDA's National Coldwater Marine Aquaculture Center. At the center, we work cooperatively with industry, scientists, and other marine organizations to grow and improve the aquaculture business sector in Maine. Over the past 20 years, the center has evolved into one of the most advanced aquaculture business incubators in North America, providing Maine companies access to state-of-the-art aquaculture infrastructure, enabling them to overcome some of the most critical challenges that face new aquaculture ventures. We offer our industry partners a clean water supply, land-based recirculating aquaculture systems, water treatment and discharge infrastructure, comprehensive permitting, and 24-hour site monitoring. In addition to this, the center provides support and training throughout the business development process. Over the years, the center has had the privilege of hosting industry partners that are revolutionizing aquaculture production in Maine. With a mission to help reduce fishing pressure on the world's coral reefs by providing aquarium hobbyists with 100% captive-bred marine ornamental fish, Sea and Reef Aquaculture was founded in 2003 by Soren Hansen. In 2012, Sea and Reef Aquaculture expanded their operations by moving into the center's Maine Aquaculture Business Incubator. Sea and Reef Aquaculture is currently the second largest producer of marine ornamentals in the United States. American Unagi is currently utilizing several of the center's recirculating aquaculture systems to expand their eel production and train their staff while they work to construct a land-based facility in the Mid-Coast region of Maine. This company grows out locally sourced American glass eels to market size and provides their customers with a fully traceable product. Springtide Seaweed got their start here as well, leasing out nursery and processing space to grow their company into the largest organic seaweed farm in North America. They currently operate a production facility in Goldsboro, Maine. Much of the center's 24,000 square foot Taunton Bay Marine Hatchery is currently being used by our industry partner, Kingfish Maine, to produce Pacific Yellowtail while they develop their 90-acre site in Jonesport, Maine. Aquaculture is the fastest growing food production sector in the world, and Maine is uniquely positioned to become a leader. As interest in Maine aquaculture grows, the Center for Cooperative Aquaculture Research will continue to grow with it.
Brian Beal and I'll introduce him in a moment, but he is at the University of Maine, Machias. He's a professor of marine ecology, but also does a lot of work at the Downeast Institute. And I think he's going to show us outside of his window because he's in a really fantastic place. But I will introduce Brian and let him talk a little bit about that place, and then we have a short video for him to share as well. So Brian is a graduate of the University of Maine at Machias. Should I say the year, Brian?
Go ahead.
1979, having grown up near Jonesport. He teaches courses in marine ecology, applied statistics, experimental design and analysis, and aquaculture. He is an experimental ecologist and conducts field work that relates to the ecology of cultured and wild shellfish, with a primary focus on commercially important species such as softshell clams, lobsters, oysters, and mussels. In addition to his teaching and research activities, Brian is the director of research at the Downeast Institute, which serves as UMaine Machias's Marine Science Field Station. Off to you, Brian.
All right. Well, thank you all for joining us today. And I also see who's on some of the attendees. And I know that there's one guy named Frank Dorsey who's got the best license plate in the state of Maine. It's called Biostat. So, hey, Frank, how are you? Hope you're doing well. So again, my name is Brian Beal, and I work and teach at the University of Maine at Machias. We have a very hands-on marine biology program. We have 48 credits of our program. Gail Kraus will be talking a little bit more about that, but we have 3 different concentrations, one in marine ecology, one in aquaculture, and one in coastal conservation. As Gail said, I'm also the director of the Marine Science Field Station at the Downeast Institute. And the Downeast Institute is a nonprofit organization that is aligned with the University of Maine at Machias and University of Maine. And that's where we do an awful lot of our research, mostly on bivalves, mostly on shellfish, but we also are doing research on lobsters as well. Right now, we're actually culturing 9 different species of bivalves, from 2 species of oysters and 4 or 5 species of clams, as well as scallops, razor clams, Arctic surf clams. And we do all of that with the notion of learning more about those species in the wild. And with softshell clams in particular, we're working with communities up and down the coast to enhance clam flats so that clammers and others that are in that industry can make more money. We've been researching softshell clams since 1987. And I think right now what we want to do is show you a short video of one of the things that we do in our program is called Semester by the Sea. The University of Maine has one that occurs in the fall. Ours occurs in the spring, and we'll be teaching it next spring. So if we could have that video keyed up, that'd be great. Let's see if this one works, shall we, Gail?
In 2000, we created a BS program in marine biology. And we always had in our minds that part of that program would have a semester by the sea, but we had no infrastructure. And working with the Downeast Institute, we ended up with a beautiful place that students can come for a semester. We have an expanded shellfish hatchery, a marine ecology wet lab, several different kinds of dry labs, as well as office spaces, a touch tank, and lots of different tanks with running and static seawater. The scope for hands-on activities is just absolutely incredible. In addition, we have a beautiful dormitory, Evelyn Hall, where folks can stay. There's a commercial kitchen. There's all the amenities that you would have if you were living either in Orono or Machias or wherever it is that you're going to the university. This Semester by the Sea is a hands-on experience. It takes students out into the field. It also gives them experience in the lab, doing shellfish mariculture in the lab, doing outside field experiments in the rocky shore and on intertidal mudflats. It's going to be a great experience, and we hope that you can make it.
So that's about what we're doing at the University of Maine at Machias at the moment. So I guess I'll just hand it off back to Gail again.
Great, thanks, Brian. And I think we're going to show one more video, and I just will mention that we are going to post these videos on the UMaine Marine website, and I put the link in the chat, but I'll put that in there again. So you will be able to, we'll make sure the CCAR video does play through. But I just will mention one more location where we have a field location that actually you've heard about several times already, which is the Darling Marine Center. And the next video that we'll show, I will introduce for now. And this is a video of a student whose work is being done out of the Darling Marine Center. And you'll hear a little bit about that. And Heather Leslie, who's the director there, couldn't join us today, but certainly would entertain questions and visits from folks to that location. So Cassie Lehman, who will be pictured in this video, is a second-year marine biology graduate student in the Brady Lab. Prior to joining the lab, she attended Eckerd College and graduated with a Bachelor of Science degree in marine science. And her research, which you'll learn about in a moment, seeks to identify where the stress points are within Maine's lobster supply chain that influence post-harvest mortality of lobsters. So, Tammy, if we can cue that.
Hi everyone, I'm Cassie. I'm a marine biology graduate student at the University of Maine, and in the next 5 minutes, I'm going to give you a crash course on what Maine's lobster supply chain is, the research I'm a part of that focuses in on the supply chain, and check in with you folks on what I've been doing recently to prep our heart rate monitors, the little backpacks you see on the lobsters and some of the footage throughout the video, for our upcoming field season. If I asked you what image or memory pops up in your mind when I say Maine, you may first think of lobster, and we all know that lobster is a huge icon for Maine, and that's no surprise as it's the most valuable single species fisheries in the entire United States. But have you ever wondered what kind of journey does a lobster experience before it reaches your plate? Let me walk you through Maine's lobster supply chain. The supply chain begins at the bottom of the ocean when a lobster gets caught in a trap. It's then hauled by a fisherman and it's put on a tank in the boat. When the fisherman is done with their day, they bring the lobsters to a wharf where they're transferred to crates and they're held at the dock or an indoor tank facility. Later that day or the next day, a truck will come and it'll bring the crates to a lobster dealer or wholesaler. From there, lobsters will be shipped domestically or internationally where they're delivered to a grocery store, a restaurant, or sometimes directly to a consumer. During a lobster's time in the supply chain, they are subjected to all kinds of different stresses, such as fast changes in temperature, pressure, air exposure, or handling. And the stress that the lobster endures while in the supply chain can sometimes result in mortality. And that's where the research that I'm a part of comes in. The University of Maine Lobster Institute created a team of industry members and researchers to come together and monitor and understand what kinds of stressors are there in the supply chain and how do those stressors influence mortality. And then together we'll come up with mitigation strategies to lessen the impacts from those stressors. And the results from this will allow the industry to become more valuable and resilient. Our team consists of members from the Maine Lobster Dealers Association, the Maine Lobstermen's Association, Ready Seafood, Luke's Lobster, and Inland Seafood, as well as researchers from the University of Maine, St. Joseph's College, and Wells National Estuarine Research Reserve. The collaborative nature of our team allows us to share perspectives and ideas on the research, and it strengthens our procedure and presumably our results as well. So how do we monitor the supply chain for these stressors? First, we are monitoring each stage in the supply chain from trap all the way to dealer, and we're observing different kinds of environmental conditions such as the temperature, dissolved oxygen, or motion. And one of our team members, Ben Gutzler, created a novel heart rate monitor that will tell us the heart rate of lobsters, which is a great indicator of stress. We are also looking at the physical conditions of the lobsters after they go through the supply chain so we can find the relationships between the environmental data that we collect and the lobster's physical condition. The heart rate monitors are super cool and I've been prepping them for the field season, so let's go visit the Darling Marine Center's new flowing seawater lab to learn more about those. I want to make sure that all the equipment that we are planning to put in the field works properly, there's no problems, and they're all calibrated correctly. So this is what I'm doing right now. I have these test lobsters, and I'm putting on heart rate monitors to make sure that our heart rate monitors are doing exactly what they should be. So here's a test lobster I have. I have each of them labeled, and this heart rate monitor is attached with zip ties. It goes over its body, lays on its back. Its legs still have total mobility and movement. And it records the heart rate at the back side of its carapace, and that's where the heart is. And records 2 times a second. And so after a few days, I'll take it off the lobster, look at the data, and make sure that everything is looking good and there's no bugs or problems. Here you can see what the heart rate data looks like. On the top panel, there's an activity index. So you can think of this as movement. And then on the lower panel, there's heart rate. And this is of a lobster moving throughout a simulated supply chain for about 48 hours. And it goes from a trap to a tank on board a boat to a refrigerated tank at a dealer, and it's known as a purge tank. And then it's moved to a second holding tank after grading. Note this low lobster activity but high heart rate while it's in the trap, high activity and high heart rate while it's on the tank in a boat, and then there's a depressed activity and heart rate once it's transferred to these chilled storage tanks on shore. The arrows mark a sudden change in the lobster's heart rate and activity, and this indicates to us a potentially stressful time point. Data like this is a great example that shows the potential value of this type of monitoring for assessing stressors, and this will help us determine mitigation strategies to lessen these stressors. Thank you so much for coming and listening about the Maine lobster supply chain and the research that we're doing here. If you have any questions about what I just talked about, please feel free to reach out to me. My email is here on the screen, and I would love to answer any questions that you might have.
Well, there we have it. So I think that that gives you a smattering of some of the things that are being done across the coast and associated with the University of Maine. And we have our panelists here. I see one question so far, but I wanted to introduce you to a couple more people who are here with us. So I'll say that Cassie wanted to be with us, but she couldn't today. Heather Leslie, who's the director of the Darling Marine Center, and Rick Wally, who's the director of the Lobster Institute, both wanted to be here as well, but couldn't. So I just wanted to mention them. But I'll also point out we have online here Neil Pettigrew. Neil, if you want to wave, who's a physical oceanographer here at the university. You actually saw him in the SMS video. He's a physical oceanographer who graduated from the MIT Hui Joint Program in Oceanography. And he's been on the faculty at UMaine since 1991, and his research is focused on the circulation of the Gulf of Maine and its bays. Since 1998, Neil has been the director of the Physical Oceanography Group, and since 2000, the director of the University of Maine Ocean Observing System, which includes a real-time data fixed buoy array, and that's the one that the fishermen were talking about in the video, as well as sea gliders and travel autonomously between the buoys, providing spatial ocean water property surveys without the need for research ships. And I'll say, and Neil was on my PhD committee, and I worked with Neil. I try to get him as much as possible to detect fish on his buoys as well. So Neil, if you want to say hi.
Hi, everyone.
And I'll also introduce you to Gail Kraus, and I'll have her tell you a little bit about her backdrop, but she's at the University of Maine, Machias. Gail teaches several marine-related courses there, and these include a first-year course in oceanography that has weekly field trips to local marine ecosystems. She also teaches a marine mammal course. In addition to field and laboratory work for the course, UMaine Machias is part of the Marine Mammal Stranding Network, where they rescue seal pups and participate in necropsies of seals and whales. She and her students maintain many marine and freshwater aquaria, which are used in ichthyology, invertebrate zoology, and other courses. And Gail also loves to study plankton, so the entire food web. Gail, do you want to say hi?
Hi, everyone. I'm a professor of marine ecology here and have been here since 1980. So one of the old timers again. And I particularly wanted to sit here because you can see this handsome critter behind me. This was our first seal articulation. And she has quite a story. It's a very old individual, or was a very old individual, a gray seal female. And we found it dead in Lubeck. We went out to take the basic data from this animal. And when we did the dissection, we found she was nearly full term, had a beautiful pup inside her. She was shot in the neck, and probably because of being around the salmon pens over on the Canadian side of it. And she washed ashore in Lubeck. So my students were so upset about this little pup that we decided to articulate it and put them back together. She was old, I think, because of the wear on her teeth. So the poor thing was probably very hungry, trying to support this pup as well. So this is just one of the things our students do. And as I said, or Gail said, we have to come up with different names so we know which Gail we're talking about. But as Gail said, I do a wide range of courses, all with a lot of field work, all with a lot of laboratory work, lots of hands-on, lots of career types of activities in it. So I hope you'll have some questions for me.
Thanks, Gail. And thank you for the reminder. Feel free to type some questions into the question and answer box. I'll also watch the chat box, but there is one question in the question and answer box, which is, if you were to state the 5 biggest problems in the Gulf of Maine's ecosystems face today, what would they be? So I've already asked Dave if he'll give it the first shot, but anybody else on the panel, feel free to help.
Thanks. The short answer is, I don't know. But if I'm forced to give some kind of a speculation, I'd couch it in a couple of different ways. One is, what are the challenges that the ecosystems face? Well, I think the ecosystems are going to adjust. We just may not like the way they adjust to any changes that are occurring in the environment. The real question is, what is happening to the Gulf of Maine that may affect our lives here, living on its edges and using it? And I would categorize them as, one, changing population levels of commercially exploited species. It wasn't too long ago when the lobster catch was steady at 20 million pounds a year. Now it's averaging 100 million pounds a year. How did that happen? Why did that happen? I'm not convinced it's been answered. Brian has shown that the densities of green crabs have just blown all out of proportion, probably related to very warm waters, especially in 2012. So what's going on now? Is it going back? There are changes in herring populations. Apparently herring are very low now. Shrimp haven't been commercially fished for about 5 or 6 years because of population levels. I could go on. So what is causing all this? Well, we've all heard that the Gulf of Maine is warming. I would couch it in a slightly different language. I would say that the Gulf of Maine has been undergoing flip-flops in temperatures. And what we never hear about is the Gulf of Maine's salinities are also changing. It's not just warming, but when we do see these warming events, they're accompanied by higher salinities. And that tells us that what's happening is not so much the sun is heating the waters more so in recent years than it is worldwide, but it's not responsible for these extreme temperatures we're seeing in the Gulf of Maine so much as influxes of high salinity, warmer waters from offshore. We don't really understand what's driving that, but it's happening. We need to understand it, because one of the effects of that, perhaps, and I'm going to ask Neil to jump in here because I'm getting out on thin ice, but in terms of ice, the Arctic Ocean is melting, which sea ice is fresh water. And so that melting of sea ice floating there in the Arctic Ocean is creating a lot of fresh water. And some of it we think is coming down the east coast of North America, along the shelf edges and entering the Gulf of Maine as a lower salinity, not completely fresh, but lower salinity water. And it may be at least partially responsible to strange fluctuations we're seeing in sea level as recorded by tide gauges. Every once in a while, you'll see the NOAA charts will predict a high tide of a certain level, but the observed high tide may be as much as 13 inches higher. I said to one of my classes just a week ago that given these big flip-flops or these big events in tidal ranges that we're seeing, or sea level height we're seeing, that can last for months or longer, that we're going to lose our salt marshes. Salt marshes only exist in situations where sea level is rising, but at a rate that's exactly matched by the influx of sediments both from the land and the ocean. So the salt marshes will build up in keeping with sea level. If sea level rises too fast, the marshes are going to erode. We're seeing evidence of that now in eastern Maine. So there are a lot of environmental changes. One of the newsy items too is ocean acidification, and that's a problem worldwide. It's a huge problem for the Great Barrier Reef off Australia. Once we mess around with the carbonate system by adding CO2, which makes carbonic acid, we're going to affect the rates at which organisms can precipitate calcium carbonate. But more importantly, I think organisms can handle a slight change in that. But what cannot be altered is the carbonate reefs that these corals create will dissolve. So ocean acidification is important. Much ocean acidification that we see in coastal waters is natural, where the production of organic matter that sinks and rots, consumes oxygen, puts out CO2, that makes acidified waters. So we have to be able to sort out these natural acidification events in estuaries and harbors from the global increase that's being driven by atmospheric CO2. So that's a long babbling answer to a very complicated question. So I'll go back to my opening comment, which is, I don't know.
Wow. Can I share my screen for just a second, Gail?
I believe, Tammy, I think you need to let that happen. I think you can, though, yes.
Okay. I'm just going to share my screen for just a second here and bolster what Dave had to say. There's a data set out there that started in 1903 in Boothbay Harbor. And what I did a few years ago was to take or actually this past year, was to take a look at all the wintertime temperatures since 1948. That is to say that the temperatures between January and March. And these are sea surface temperatures in Boothbay Harbor. And you can see that since the mid-1960s, there's been decadal increases in seawater temperature in the wintertime. That is to say, our wintertime temperatures are getting warmer and warmer. And that means that there's less ice around. Dave mentioned also that, I'll stop the share right now so you can see everybody else. But Dave mentioned this problem with green crabs, an invasive species, although they've been in Maine for almost over 100 years now. And temperatures drives the ecology, essentially, of the Gulf. And whether that's lobsters or whether that's green crabs or whether that's soft-shell clams, everything relates back to temperature. And so I would say that the primary driver of ecosystems in the Gulf is temperature. And it's up to the physical oceanographers to tell us, why the temperatures are climbing. But biologically and ecologically, that actually moves the mountain.
Neil, sounds like you're on the hot seat there.
Well, I guess I could say the same thing Dave did, but with regard to not really knowing. But I guess the thing that I think is probably the most important is actually not so much the melting that happens more and more every year in the Arctic, but really the melting that's going on the Greenland ice sheet. And when that actually melts and goes onto the water, goes into the ocean, then it really does raise sea level. And as I think Dave was suggesting, actually the rise of sea level is somewhat trapped close to the shoreline. And this due to what we call the Coriolis effect and the rotation of the Earth. And so as it tries to go offshore, it gets trapped and goes along the shore. And so at first, if you're thinking about the west side of Greenland, where most of the meltwater is happening, that's going to head north first, and it turns around back to the south through the Labrador Sea and eventually winds up right. Some of it, most of it doesn't get here, but some of it comes right into the Gulf of Maine. And I'd say we saw changes in two things. We saw changes in circulation in the Gulf of Maine, right around 2005, 2004. And at the same time, this is really interesting because at the same time, we saw a big decrease salinity. And just to add one more factor, there was a model that had been running for many, many years, and that was the first year that, since they had started running it anyway, that they saw meltwater come all the way from Greenland and enter into the Gulf of Maine that year. And so when that happened, it changed the way the circulation happened. It changed the amount of the slope water, which has the nutrients that come in. It changed that for the year. And it's honestly been different ever since, although it's not as strong as it was that year when it first happened. But we just have these results, and the fresh water coming in does a lot, including pressing down the salty water that has the higher nutrients that normally come into the Northeast Channel. I'm probably giving too many details, but.
No, that's helpful. Thanks, Neil. So we do have another question in the question and answer box, which is, as a high schooler, how can someone get involved in these efforts? Does anybody have a specific answer to that? I'm wondering if Alex, as a student, how you were able to become involved.
Yeah, I mean, I was just really interested. My classes really intrigued me. I've always had a passion for marine science. So I definitely just really wanted to get involved with things. So I guess my biggest recommendation is just get involved, talk to people, do a little research, talk to the people at, ARI and the Aquaculture Research Center, get involved with clubs like Marine Science Club. We have a new aquaculture club. It's kind of stalled right now, obviously, because of the pandemic. But yeah, just get involved with things like that. And also take every opportunity that you can. So like we were talking about, Semester by the Sea, definitely do that. Really cool. Unfortunately, I did it online, but it was still really cool. Met some really cool professors there. So yeah, make connections.
How about at UMaine Machias? Do you guys have thoughts for high schoolers?
Sure.
Well, there is an early college program.
Yeah. Well, just like what Alex was saying, if you come to the University of Maine or you come to the University of Maine in Machias, come and find us. We've got all kinds of things happening, and all you have to do is talk about, what it is that you're interested in, and we will find you something to do. And that's about as basic as it gets.
Any other thoughts? There is one more question to move to, unless somebody has another thought of how to get high schoolers engaged. Steve at CCAR?
Yeah, I would just add, there's a lot of great private groups that focus on conservation activities in the Gulf of Maine. And we have a member here, Brian pointed him out, Frank Dorsey, who's with the Friends of Taunton Bay. They do some really cool stuff in Taunton Bay in April, May, and June with horseshoe crab surveys. And I'm sure that they would welcome some high school members and some new blood, and a lot of these other groups up and down the coast would as well.
Great. Dave, did you have thoughts from the School of Marine Sciences point of view?
Well, yeah, I was just going to tell this young person to get good grades, apply to school, either here or Machias. In a while, it's not going to make any difference. We're one university, essentially. Yeah, I'd love to have you in my classes, and we can talk about anything you want to talk about. I'm sure Brian and Gail feel the same way.
Mm-hmm. Yeah, and feel free to reach out to the Sea Grant program. We're connected with a lot of the groups that Steve's mentioning, so we could probably connect you up with some community science work. And coming into the university system, it's nice. I think that we're looking for people who are passionate. So the more you can kind of build that into your DNA, the better, in terms of coming to the university. So another question. Oh, go ahead, Brian.
I'll also add one more thing, and that is during the summer at DEI, in typical years, we run marine science summer camps for youth. We have K to 3 and 4 to 6, and we have 8 through 12. So if you're a high schooler and you want to do something in the summer before you get to college, we've got opportunities, at least at the Downeast Institute, that you can hands-on activities that run 6 to 8 hours a day for 3 or 4 days a week in the summer.
Great. So Patrick, I hope you have some ideas there. I think there were a few. Feel free to reach back to us too. I put the web link in the chat. I'll do it again, but we can also put in some emails for you to connect with. So we have another question here that is, can someone speak more to UMaine Marine? How it is novel and what the initiative has planned to specifically make the UMaine system more competitive, especially thinking about student engagement. I'll give it a little bit of a shot and then I'll let other people add. So the UMaine Marine initiative is new, as I mentioned at the beginning, and it's really a space like this to get us all to be talking to each other to leverage what we do more effectively. So it's doing activities like this to get us building our network of folks and what do we see as opportunities. And we really think that pulling our expertise together across the entire state could leverage different opportunities. So between UMaine, Machias, and I know that the question is on student engagement, both undergraduate and graduate. So what are the opportunities? How do we connect our students to one another? And so those are the exact questions we're asking right now, and we're rolling this out so that we can better build that network. So there are other groups at the University of Maine working in the marine space that we still will be rolling in and really want to start more of these conversations. Dave.
Yeah, I can just add a little historical context. Having been around for a long time, back before I came to Maine, I used to work at Bigelow Laboratory in the early 1980s, and we formed a similar group in Maine that was called the Association for Research in the Gulf of Maine, and it was a few institutions: Bigelow Lab, University of Maine, Maine Geological Survey, Maine Maritime Academy. I can't remember who else, but the point was we started out just like this. We wanted to talk and engage and talk about the challenges to doing, in that case, research in the Gulf of Maine. And what it led to was the creation of what became known as the Mitchell Act, which was 5 or 8 years of funding by NOAA for research dedicated to the Gulf of Maine. I know Neil has done, did a lot of work with funding from that operation. We also won a ship from UNOS, the University National Oceanographic Laboratory System, what was being given away with a competitive proposal, the research vessel Cayuse. It later became the research vessel Argo Maine. It's been retired now for quite some time, but that was a big jump that we took in our understanding and efforts to study the Gulf of Maine, a huge jump. And so this could be yet another of these steps that we will see the benefits of. Now, in terms of undergraduate research involvement, of course, this is President Farini Mundy's initiative, and we're all struggling with this. Here in the School of Marine Sciences, of course, we already do it as a outgoing senior capstone experience, but now how do we build it into a freshman experience and what is being called not just a research experience, but an authentic research experience? And how do we do that? It's a challenge because, we're going to have about 2,000 freshman first-year students coming in the fall. How do we do it? Whether this organizational initiative can find a solution to how that might happen, I don't think so. It's going to take more of an academic college and department structural approach, both here and in Machias. But I think I was a naysayer when this first started, when Vice President Baharomian began to talk about it, and I still see it as a larger effort. I think we need to go statewide, not just University of Maine, Machias. But this is how it starts, and we keep up these kinds of efforts. I think it will pay dividends at some point. How can it not?
I guess I'll also just point out there is some structure around this. So there is a steering committee. Most of the folks who are here right now are on that steering committee. There's an internal advisory board and we're forming up an external advisory board. So those are regularly meeting. The steering committee has been meeting. They're generally directors of these institutions or these programs within the university, meeting roughly monthly. And then the internal advisory committee is mostly deans, and at a higher administrative level, and we'll be meeting with them once a semester. And again, we're trying to form up an external advisory board associated with that. So it's not just this webinar. It's not going to end when we leave the webinar. So you'll hear more, and feel free to reach out for more information. I'm going to acknowledge that it's 4:01. So we had said that this would go till 4, but I will also acknowledge that there's one more question in the question and answer box. If it's okay, if folks want to stay on, feel free to not. But the question that's out there, I'm going to pitch it to Debbie Bouchard. How do you see the role of aquaculture evolving in Maine over the next 10 years, both biologically and in Maine's marine economy? Steve, you're on, batter up.
So Dave led us all with the best answer of all. I don't know. However, I do know that the industry currently, the aquaculture industry for the marine, is an $88.4 million industry, and it's seen rapid expansion in shellfish and sea vegetables. We also have an influx of companies coming in interested in doing land-based aquaculture, that the capital investment being proposed by these companies is almost $2 billion. So we need to grow the aquaculture industry in a sustainable way. We need to pick the organisms that are going to grow well in our environment. And the Aquaculture Research Institute hopes to engage in doing research with all of this in order to make the aquaculture industry sustainable in Maine and the nation.
Steve, did you want to add any 2 cents?
I would add also that what we're seeing is there's a tension between these new companies that are coming in and proposing some really large projects and what people are calling industrial aquaculture versus the traditional aquaculture we've had in Maine, which is small, with the exception of the salmon farming sector. Family-owned shellfish farmers, seaweed farmers, small scale. And so you're seeing this debate begin to evolve, and there's currently some legislation being proposed to address some of these issues regarding the size of leases, passing leases on to other people, and really what is the suitable scale of aquaculture in the state. I think we can have both. What I would really hate to see is all of the oyster farmers bought out by one company and turned into one large industrial oyster farm. So I think we need to beware of that, but I think there's people who are certainly very aware of that issue now and are working to preserve the small family farms. But at the same time, there is room for large scale facilities in Maine. We just need to strike a balance.
Great.
I'll end with one word.
Okay.
The answer to that question: exponentially.